You know, for most of us developers, writing tests can feel like, well, a chore, right? It's that last box you have to check before you can finally ship your code. But what if? What if we've been looking at it all wrong? Let's dive into this idea that testing isn't just about confirming things work. It's actually about discovery. It's a tool for thinking, and it can show you the things you don't even realize you don't know.
And this whole idea, it's just perfectly captured in this one moment of realization from a junior software engineer, a guy named Timothy. So get this, he spent a whole day writing tests for a feature that was, for all intents and purposes, already done. And at the end of all that, he said this: it wasn't about finding bugs in the code, not really. It was about finding gaps in his own understanding.
So, what were these gaps in his understanding? I mean, what did he actually find? It's such a great question because the answer really gets to the heart of why this whole shift in mindset is, well, it's a total game changer.
Yeah, this was not your typical debugging session. Timothy's feature was, by all accounts, finished. Done. But he just had this nagging feeling, a pull to keep poking at it, to keep writing more tests. And in that quiet, extra bit of work, that's when he had his breakthrough. And what he found wasn't simple stuff like typos or syntax errors. No. What his tests revealed was way deeper. Things like 3 incorrect assumptions he'd made about the input data, 2 edge cases he hadn't even thought about. And get this, 1 hidden interaction with some old dusty corner of the system. See? The bugs were just the symptoms of a much bigger problem. His senior mentor, a woman named Margaret, she saw exactly what was going on, and she just nailed it with this piece of wisdom she shared. She said, the real value, it isn't the test you end up with. The destination isn't the test. The destination is the thinking that you have to do to even get to that test. And that, right there, perfectly illustrates the core idea here. You see, we need to shift the main question we're asking. It's super easy to ask, hey, does my code work? But it's so much harder and way more valuable to step back and ask, wait a minute, did I even build the right thing in the first place? Okay, let's break this down. On one hand, you have the old way, testing as confirmation. This just proves that your code does what you believe it does. But here's the thing, if your own thinking is flawed, well, your tests are going to be flawed too. They just inherit all your blind spots. But the new way, testing as thinking, it forces you to sit down and specify what correct behavior actually is, down to the last detail. And when you do that, boom, it can't help but reveal those blind spots. Timothy put it perfectly. He realized, wow, I actually don't know what the right answer is for this specific input. And that realization, that not knowing, that was the most valuable thing he discovered all day. The test didn't hand him an answer. It forced him to find the question he should have been asking all along. Okay, so if this way of thinking about tests is so much better, you have to wonder, right? Why isn't everybody doing this all the time? Well, it comes down to something really practical. You could even say economic. And this, right here, is where AI coding assistants just completely change the math. Yeah, let's just ask that question point blank. If this is so clearly a better way to build solid, robust software, why has it always been the exception instead of the rule? The simple truth, it's slow. It just is. Thinking this deeply about every single edge case, every possible input, it takes a ton of time. And frankly, it takes a level of experience that a lot of developers are still working towards. So what happens when the pressure is on and deadlines are looming? You guessed it. This kind of deep testing is almost always the first thing to get cut. But that's the calculation that AI tools like Claude Code are completely flipping on its head. It fundamentally changes that cost-benefit analysis. Suddenly, the time and effort it takes to do this kind of deep thinking, it becomes practical, even when you're under pressure. And here's how it works. Think about it. An AI like Claude Code can do so much more than just spit out test code. You can actually ask it, hey, what are the tricky cases I'm probably missing here? You can literally prompt it to model the perspective of a senior engineer. It's not there to replace your thinking. It's there to give you a scaffold, a framework to make your own thinking way more powerful and a whole lot more efficient. Okay, but hold on. Using AI for testing isn't as simple as just typing write tests for my code. There is a huge trap here that a lot of developers fall right into, and avoiding it all comes down to how you ask. The prompt. The prompt is the real skill. So here's the absolute crucial point. You have to test behavior, not implementation. Let me say that again. Behavior, not implementation. See, if you just ask an AI to test the code you already wrote, it's going to write tests that check if the code runs in that one specific way. And those tests, they're brittle. They break the second you refactor anything.
The real goal is to test behavior, to ask, if I give it this input, do I get the right output, no matter how the sausage gets made inside? Those are the tests that last. And this leads us to what is probably the single most important takeaway here. Here's the golden rule. Don't give the AI your code. Don't show it your solution. Instead, give it the specification, the description of the problem, and ask it to generate tests from that. That way, you're testing the what, not the how. And once you make that shift, it just opens up this whole new world of incredibly powerful prompts. You're not just saying, write tests anymore. Now, you can ask the AI to be a real thinking partner. Identify edge cases I haven't considered. What would a senior engineer insist on testing here? Or, my favorite, explain why this test fails. Don't just fix it. Because that explanation, man, that's where the real learning happens.
So when you put all these pieces together, what do you end up with? It's not just a folder full of test files, it's something way, way more powerful. You end up with a system that's constantly asking questions for you, building this incredible safety net for everything you do in the future.
This new workflow really breaks down into 3 clear roles. First, the test is your detector. It just tells you what is wrong. Then the AI is your diagnostician. It helps you understand why it's wrong. And that leaves you, the developer, in the most critical role of all. You're the decision maker. You get to decide how to solve the problem armed with all that information.
So, with all this in mind, maybe we need to redefine what a good test suite even is. It's not just some static checklist you run. A truly great test suite is a living, breathing part of your work. It's a system you build that keeps asking the hard questions for you, every single time the code changes, long after you've forgotten the details and moved on to something new.
And the ultimate payoff for all this, well, Margaret just sums it up perfectly. She said, a codebase that's safe to change is a codebase that can grow without accumulating fear. And that's it, isn't it? When developers aren't afraid to make changes, to refactor, to improve things, that's when software can really evolve, instead of just becoming this tangled, fragile mess. You're not just coding for today, you're building for the future.
So I'll just leave you with this one thought. Every single piece of software, every feature you've ever written, it's got hidden assumptions and unasked questions buried deep inside of it. They're just sitting there, waiting. So the only real question left is, what are yours and how are you going to find them?